Hello, welcome to Easy as Pie with Mr. Carpenter. I'm Mr. Carpenter, and we're going to take this time and tackle those part twos, those part threes, and part fours of the June 2023 Regents. Let's get started. Number 25, getting us right into an equation that we're going to solve, and they use decimals, which is annoying, but it doesn't change anything that we're going to do, right? We have this three-step process. The first question is, can I distribute? And the answer is yes, I can. I can distribute the negative 2.4 out across the parentheses. So let's do that. Negative 2.4 times x is negative 2.4x. And negative 2.4 times 1.4 is negative 3.36. Nope. And that is still equal to 6.8x minus 22.68. Second question is, can I combine like terms? In this case, no, I cannot. Because as we can recall, like terms have the same variable raised to the same exponent, and they're on the same side of the equal sign. And so in that case, no, there's no like terms that can be combined here. So we can jump to step 3, which is solving, right? I want my variables. I don't want variables on both sides, so I'm going to move one of them over to join the other. And I'm going to pick moving the negative 2.4, because when I do that, I'm going to be adding 2.4x to both sides, and that will cause me to be working with positive numbers, which we always love. Those cross off. We have negative 3.36 equals 6.8 plus 2.4 is 9.2x minus 22.68. And from here, it should look like a pretty simple two-step equation. The opposite of subtracting 22.68 is to add 22.68. So we got 9.2x equals 19.32. And the opposite of multiplying by 9.2 is to divide by 9.2. You'll get an answer of 2.1, and that is your final answer. Moving on, number 26, the function is graphed on the set of axes below. State the zeros of f of x. Now, zeros is the same thing as solutions, is the same thing as x-intercepts. They are the same. Equals roots, the roots of the function. They all mean the same thing. The points, the values of x that cause the function to have an output of 0. The only mistake you can really make is using that one. That is the y-intercepts, right? That's what happens when I plug in 0 for x, right? So the input is 0, so we're going to be somewhere on this y-axis line because we didn't move to the right or left or anything. Okay? So in this case, I'm going to have a 0 of negative 2, of positive 2, and a positive 3. And the reasonings are, well, it jumped a little bit. There we go. Reasoning is these values of x will make the output of f of x equal to 0. Or something to do with the fact that they're x-intercepts will also work here. Okay, moving on. 27, Brianna creates the pattern of blocks below in our class. So we got first drawing has 4 blocks. Second drawing has 6 blocks, the third drawing has 8 blocks, and the fourth drawing has 10 blocks. A friend tells her that the number of blocks in the pattern is increasing exponentially. Is her friend correct? So if we're looking at exponential growth, then we're looking at a non-constant rate of change. Right? If I have a linear function, then the rate of change is going to be consistent every time. And you'll notice, right, to get from the first block to the second block, we're increasing by 2. And to get from the second to the third, we increase by 2. And to get from the third to the fourth, we increase by 2. So if I were to graph this, right, where the x-axis is it's the order of drawings, and the y-axis is the number of blocks, I'm gonna get something like this, where the first drawing has 2 blocks, so 1, 2, or the first drawing has 4 blocks, sorry, so the first drawing has 4 blocks, the second drawing has 6 blocks, the third drawing has 8 blocks, and we're gonna get linear growth here because it's a consistent slope. 2 blocks increase per drawing. So no, she is not correct. The rate of change is consistent or constant, making it linear. Boom. I'm guessing there's no... oh, there we go. Got rid of it. Number 28, a box plot. So, essentially, if you remember, we're going to go with the stat button, then edit, and then we're going to put this data in a list, which I should have done beforehand, but shouldn't be too bad. So we got 20, 36, 52, 56, 24, 16, 40, 4, and 28. Okay. And then, so put numbers in or put data in. Then we're going back to stats, then calc, then one var stats. And that will give us what we want, which is our 5-number summary. So the minimum value is 4. The first quartile is 18. The median is 28. The third quartile is 46. And the maximum is 56. And every single one of these is going to become a line that goes above the number line. So this is going up by 4s because it's 4, 8, 12, 16, 20. So that minimum is 4, so there's that. First quartile is 18, so 4, 8, 12, 16, halfway between 16, 8, 16, and 20. Median is 28, 20, 24, 28. Third quartile is 46, 44, so in between 44 and 48. And the maximum is 56, so 44, 40, 52, 56. So those 5 lines. And if you want to like write out, label it all so you don't mess something up, that is a-okay as well. Then we box the middle 3 and we make tails to the end 2, and that is a box plot. Given a is equal to x squared plus 5 and b is equal to x squared minus 18, we want to express a squared plus b in standard form. And this is where we're going to have to think a little bit, find some structure in mathematics. We have a squared. A is equal to x plus 5. Things that are equal are interchangeable. So when I think of a squared, I'm going to think of x plus 5, which was a squared. Okay, and this is not x squared plus 5 squared. You are going to write it out as repeated multiplication. So we got x plus 5 times x plus 5. We'll double distribute or make a table, whatever your heart desires. X times x is x squared. X times 5 is 5x. 5 times x is 5x. And 5 times 5 is 25. And then all it's left to just combine like terms and get x squared plus 10x plus 25. So now that I know what a squared is, a squared plus b, well, I already know what a squared is. So we have x squared plus 10x plus 25. And then I'm going to add b, so plus x squared minus 18. And now it's just a matter of combining like terms. I have these x squares that are like terms. That'll become a 2x squared. I have the 25 and the negative 18. So 25 minus 18 is 7. And then I still have that positive 10x. So plus 10x plus 7. And since we want it in standard form, it does need to be in this order of descending exponents. So x squared, then x to the first, and then the constant term. Moving on. Number 30. Both of these relations are not functions. How could we change each so that they become a function? Well, first of all, why are they not functions? Right? If you remember, functions cannot have one input giving multiple outputs, right? Two people can have the same birthday, but one person cannot have two birthdays. So specifically in relation to, right, the input -4 has two birthdays. It's -4, 0 and -4, 4. So if I'm changing relation to, right, I'm just going to remove -4, 0 from the relation. Easy as that. I don't need to be a heart surgeon and get in and change certain outputs or whatever. I'm just going to remove it. Once I remove it, it's now a function. Relation 1 fails a vertical line test. If I draw this vertical line, it crosses the function at two specific points, which means the input 4 has two birthdays, right? It's 4, 20 and 4, 30, right? So that's a problem as well. If you're wondering why it's not a problem here, it's because this is an open circle, which represents the idea that 2, 10 is not a coordinate in my function. But when we reach this point, we're going to default to a different closed point in the function. And that's how we're going to fix this. We are going, so with relation 1, all right, I'm just going to remove 4, 20 from the relation. And you could also make 4, 20 an open circle, representing it's approaching that coordinate, but that coordinate isn't actually part of my relation. There's more than one way to answer this question as long as you understand what a function is and how we can change them accordingly to get that desired result. Number 31, factoring. Factoring. 3 methods of factoring: GCF, DOPS, and trinomials. And everyone's going to say that this is a trinomial, and you are correct. Problem is this trinomial has a coefficient of 2. We don't know how to factor trinomials with a coefficient of 2, which is why I always tell you, if you can GCF, you will GCF. Always. If you can GCF, you will GCF. And then if it's still factorable in other ways, you'll explore those options then. So in this case, greatest common factor, I can think of greatest common factor as factoring the numbers and the variables. I can only GCF variables if every term has that variable. These two terms have an x. This one does not. So there is no greatest common factor of the variables. What about the numbers? We have 2, 16, and -18. Is there a number that divides nicely into all three of those terms? And the answer is yes. I can factor out a 2 because 2 goes nicely into all of those numbers. So I'm going to write out my greatest common factor. I'm going to start my parentheses. And what goes in the parentheses is every term divided by the greatest common factor. So we got 2x squared divided by 2, which those cancel out. I'm just left with x squared. We got 16x divided by 2. which is 16 divided by 2 is 8, and we're going to slap that x back there, plus 8x. Then lastly, we have negative 18 divided by 2, which is negative 9, so that will go there. Maybe the color coding will help you out a little bit. So we factored out a 2. Now, what I see inside the parentheses is a trinomial. So how do I factor my trinomials? Well, I'm going to take factors of negative 9 that add up to positive 8. Factors of C that add up to B. Well, I could do 3 and 3, but that's not going to give me to 8. I could do 9 and 1. There's something there, right? I have to do negative 9. So really my options are negative 9 and positive 1, or positive 9 and negative 1. Well, negative 9 plus 1 is negative 8. 9 minus 1 is positive 8. And because this is a positive 8, that means I want these two factors. So this will become x plus 9 times x minus 1. And that is a fully factored quadratic. Solve this algebraically for all values of d, rounding to the nearest tenth. So normally when we solve quadratics, we want to factor. Problem, this has a coefficient of 3. Our little factoring trinomials trick up here doesn't work when my coefficient is anything other than 1. So maybe we can factor out a 3 like we did up there. Problem is 3 doesn't go nicely into 8. So I have an unfactorable quadratic that I must solve. When it's unfactorable, my two choices are either completing the square or the quadratic formula. Most people like the quadratic formula here. So let's have a look at that. So my A, B, and C values I identify. B is negative 8, and C is 3. My quadratic formula, which you do not have to memorize, which is why a lot of people like it. It's right here, laid out for us. So I'm going to go remember what it was real quick. Go back to my problem. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. Which would be negative b. If you write negative 8 here, right, b is negative 8. So negative b is negative 8 plus or minus the square root of b squared, negative 8 squared. Always put numbers raised to exponents in parentheses. Do not write negative 8 squared on the calculator. You write negative 8 squared with parentheses. Okay? So that gets its own little aside. Minus 4 times A, which is 3, times C, which is also 3. All over 2 times 3. Now, there is a chance that this will ask you to simplify this as much as you can. In which case, you're going to, find out what negative 8 squared minus 4 times 3 is. See if you can take a square root and keep going and simplify it fully. But since it just wants the answers rounded to the nearest tenth, you can put that in your calculator. And that's exactly what I'm going to do. Because you can't type a plus or minus in your calculator, you're going to make two of them. One where it's a plus, and that'll be one of your answers. And one where it's a minus, and that'll be another one of your answers. So negative 8 plus the square root of negative 8 squared minus 4 times 3 over 2 times 3. So one of my answers is 2.21, but it's nearest tenth, so really 2.2. Then I'll go back and highlight that change that plus to a minus, and get 0.45. Once again, rounding to the nearest tenth. Oop, I'm back here. Over there, which would be 0.5. Both of these are answers. Okay. Graphing. Graphing. So when we graph, we are always going to look to make a table and find its points. So here's one table where x and f of x, which just the same thing as y. And then in blue, I'll do the same thing with x and g of x, which is also y. Don't be thrown off by those. So I put these in my graphing calculator and the y equals. So we have absolute value of x plus 1. Check out its table. Oh, someone messed with this. Try that again. So some coordinates that I see here, we see 0, 1, 1, 2, 3, 4, negative 1, 2, negative 2, 3. So let's plot some of those. 0, 1, 1, 2. I'm sorry, that should be 2, 3, 2, 3, negative 1, 2, negative 2, 3. And you can pretty easily see the shape that we're going to be taking here. There. And there. And let's go into g of x, which is negative x squared plus 6x plus 1. So we got, 0, 1, negative 1, 6, 1, 6, 2, 9. I'm going to focus on the ones that will actually fit on the graph, right? So 0, 1, 1, 6, 1, 2, 3, 4, 5, 6, 2, 9, 3, 10. I'm going to keep going because I really want to get the full shape. 4, 9, 5, 6. And at this point, you can kind of see what that one's going to do as well. So, okay, undo, turn the pen off, scroll down a little bit so we can really get this full shape. Not going to be perfect. I am going to draw arrows, and I'm going to label both of my functions. So negative x squared plus 6x plus 1. And this was f of x equals absolute value of x plus 1. Graphing's done. Based on your graphs, determine all values for x for which f of x is equal to g of x. So when two functions have the same solution, we're thinking about their intersection points. So I notice, although this graph is drawn poorly, but you can see the coordinate, we have a solution here and a solution here. So what values of x led to these intersections? Well, when x was equal to 0, that led to a solution, and when x was equal to 5, that led to a solution. So we're looking at x equals 0 and x equals 5. Moving on. We're going to look at this graph. And this is showing temperatures over a 24-hour period in August in Syracuse. And we're going to put the results in the table. State the entire interval over which the temperature is increasing. So when the temperature is rising, the temperature is my y-axis. So really, all of this is increasing. So I'm going to say from hour 6 to hour 12 is increasing. State the 3-hour interval that had the greatest rate of change in temperature. Okay, so if it's going to have the greatest rate of change in temperature, it's got to be a positive number. Well, no, not necessarily. But in this case, well, it's definitely got to have the steepest slope. Okay, slope is rise over run. So perhaps I think it's this one. So rise is 1, 2, 3, 4. 1, 2, 3. Since these are in twos, this is saying it rose 8 degrees in 3 hours. So can I find a steeper slope than that? Thank you. Can I find a steeper slope than that? Well, this one's going up 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So that's going up 14 degrees in 3 hours. That slope is the steepest one I'm going to find here. So from hours 9 to 12, I have the steepest slope. State the average rate of change from hour 12 to hour 24. First thing, average rate of change is another word for slope. Slope formula is rise over run, but in coordinate form, y2 minus y1 over x2 minus x1. So what I need are two coordinates. And I know the two coordinates are on the inputs 12 and 24. So 12 comma something and 24 comma something. So I go here. We have, let's go back up to my table, right? We have 12 comma 92 and 18 comma 85. Right? Those are the outputs with their inputs. So let's go down and fix those with a 92 and an 85. And I'll label, right? This is my first input and my first output. That's my second input and that's my second output. So this will become 85 minus 92 over 24 minus 12. And if you put that into your calculator, you get negative 7 over 12. Let me make sure that's right. Okay, yes. So, this is negative 7 degrees in 12 hours, right? Because these are hours. So the proper contextual response would be decreased 7 degrees per 12 hours. Or, and if you actually go in and do 7 over 12, you get, so negative 7 over 12 is equal to negative 0.58. So we could also say decreased 0.58 degrees per hour. Forgive my sloppy handwriting. Whew, that one was a doozy. Let's move on. Graphing inequalities. First things first, you have to be able to isolate for y. You must. So I'm going to kind of do that quietly now, assuming that this is stuff that you're comfortable with. So I need y by itself. That 2x is a problem, so I'll move it over. So you got negative 2x minus 6 multiplied by 3, so I will divide by 3. Since I divided by a positive number, I will keep my inequality sign. Negative 2 over 3x. Negative 6 over 3 is negative 2. X is less than 3y plus 6. Okay, that 6 is a problem because it's on the same side as y. So we have x minus 6 is less than 3y. So divide both sides by 3. We got x over 3, so I'm going to do 1/3 x, so I have a specific slope, minus 2 is less than y. So since this alligator is going to eat the bigger number, it's going to eat the y. So y is greater than, right? I'm just writing it so that the y is in front. I don't want you to be confused as to why I'm flipping the inequality sign, right? If this is smaller than y, then y is bigger than that. So y is bigger than 1/3 x minus 2. So graphing these, I know you can table it. You can put them in tables and find their coordinates. The faster way that involves its slope and y-intercept, though. The slope of this is 1/3. Its y-intercept is -2. So plots y-intercept, -2, 0, -2. And then the slope is positive 1 over 3. So rise 1, run 3. So rise 1, run 3. And we'll get that point. Rise 1, run 3. Rise 1, run 3. Fall 1, go left 3. Right? Just keep going, kind of make the line. Since it is a strictly greater than symbol, we're going to use a dotted line. Moving on to the red one, it also has a y-intercept of -2. And its slope is -2/3. So we're going down to right 3. Down to right 3. Up to left 3. And since that is a greater than or equal to sign, we're going to make a solid line. Of course, we're not going to forget to label. So y is equal to or greater than -2/3 x minus 2. And this is y is greater than 1/3 x minus 2. If you're on the inequals app, which is in your apps, you will be able to determine the correct shading for these graphs. So I'm going to go in, I'm going to graph both of them with their inequality symbols intact. So y is greater than 1/3 x minus 2. And that's going to shade like this. And then I'm going to graph the other one. Y is greater than or equal to -2/3 x minus 2. And we get, let me get the red back. That right there. And of course, the solution set is going to be whatever fits in both categories. Is the point 4, -2 in the solution set? Well, let's go to 4, -2. 1, 2, 3, 4, 1, 2. Is that in the solution set? Well, is it in the area that's scratched by both red and blue marks, which would indicate it's a solution of both inequalities? No, it's not. It is not in the solution set and only satisfies one inequality. And that's it. Susanna collected information about a group of ponies and horses, and she's going to make a table of the height of their height measured in hands. No idea what that means, and their weight measured in pounds. And it wants a linear regression equation. So this is stats. So we're going to stat, edit, And you're going to put that data in. This is going to be my first list, and that's going to be my second list. Allow me to do that now. 11, 12, 13, 14, 15, 16, 17. 264, 638, 700, 850, 1,000, 1230, 1495. Then go back to stat. We're going to calc. And this time we're not going to do one var stats like we did to get our mean or our median or our box plot. We're going to do that lin reg ax plus b, right? Because it's going to be in the form ax plus b. So I just need to know what my a and b values are. So let's go put those in. A is 184. It wants the nearest hundredth, so 0.89. B is negative 1706.07. So filling both of those in for A and B, we get y equals 184.89x minus 1706.07. Do not forget the y equals, please. It is not a function unless it has an output variable. Correlation coefficient. Finding this requires you to have stat diagnostics on, which I will make sure we all do on Regents Day. Stat diagnostics on. And your correlation coefficient is always represented by R, not R squared, R. So R is, in this case, 0.99 because we're nearest hundredth. And what that correlation indicates, right? It is a strong positive correlation. Right? That's strong positive. If it's something like negative 0.96, that's strong negative. And if it's something like 0.1, that's a weak or no correlation. So strong positive correlation, what that means is the line of best fit, the linear fit of the data is really good. It's really strong. The line that I draw using the linear regression is going to very accurately match the data that I'm working with. So good linear fits. So it appears, once again, in context, it appears that as a horse gets taller, it gets heavier. Because as its height goes up, its weight goes up as well. One more. The dreaded part 4. No. So the part 4. Dana went shopping for plants, put in her garden. She got 3 roses and 2 daisies for $31.88, which feels like a lot for flowers, but maybe I just don't know about the flower biz. Later, she went back, bought 2 roses and 1 daisy for $18.92. We need to make a system. R is the cost of 1 rose, and D is the cost of 1 daisy. We're going to need a system of equations. We're going to need 2 unknowns, so we're going to need 2 equations. Well, I know she bought 3 roses, so 3 times the cost of a rose, plus 2 daisies, and she spent $31.88. I also know she bought 2 roses and 1 daisy for $18.92. Okay? So those are my 2 systems of equations. We need to solve this system. The easiest way I find is going to be elimination, right? If I added these together, nothing cancels out in the moment. I'd really like for that to be a -2, though. So why don't I just take this equation and multiply it by -2? So on the top, we still have 3r plus 2d is $31.88. Negative 2 times 2r is negative 4r. Negative 2 times d is minus 2d. And negative 2 times 1892 is negative 3784. And now I will add them together, knowing that the daisies will cancel. So 3 minus 3r minus 4r is negative 1r. And 3188 minus 3784 is negative 5.96. And I just got to divide by negative 1 here. So r is 596. How do I find daisies? Well, I'll just use the apple to find the orange, right? Plug in the roses into any one. I'm going to pick the second one because it looks easier. 2 times 5.96 because I know how much roses cost. Plus the daisy cost is $18.92. 2 times 5.96 is $11.92. So I just gotta subtract $11.92 for both sides. You get a nice clean 7. So $7 for a rose, $5.96 for a daisy. If Dana had waited until the plants were on sale, she would have paid $4.50 for each rose and $6.50 for each daisy. How much money would she have saved by buying all of her flowers during the sale? Well, let's think about this logistically, okay? She bought 3 roses and then went back and bought 2 roses. So she bought 5 roses for $5.96 per rose. So she spent $29.80. If she had bought them during the sale, she would have bought 5 roses for $4.50 each. And she would have only spent $22.50. So how much did she save? Well, that would just be their difference. So she would have saved $7.30 on roses. What about daisies? Well, how many daisies did she buy? Going back up, she bought 2 daisies and then bought 1 daisy. So she bought 3 daisies for $7 per daisy. So she spent $21. If she had bought it during the sale, she would have bought 3 daisies for $6.50 per daisy, which would be $19.50. So how much would she save there? She would save $1.50. I want the total amount saved, so these two guys combined together. She would have saved $8.80 total during the whole sale. And that is the whole Regents. Mr. Carpenter's out of breath because that was quite the journey we took on the 2s, 3s, and 4s. I hope this helped you. Please do not hesitate to let me know if you have any questions, and I will see you in the next video.